Today we are going to start with this 2017 January paper S1. So we will come up with the first question itself. Right. Then, yeah. So when you come up with this first question today, they mention Ralph records the weight in grams of 100 tomatoes. Right. So in this case, we need to understand this fact. The N is equal to 100. So we have to start from the question from here itself. So we need to get these facts clearly, right? This information is displayed in the histogram over here. Then they haven't given any like the frequency density column is given, but they haven't specifically mentioned what is the scale for this frequency density in this diagram. That is a usual pattern they used to give us. To find that scale, they might give you some information over here. Given that 5 of tomatoes have the weight between 2 to 3. 2 to 3, there are 5 tomatoes. Then we know that in a frequency density table, this area represents the frequency. This area represents the frequency. So how do you get this area? But I'll just get this one. I don't know this height. I just mark it as x. Then the area here is x into 1 equals to 5. Therefore, x is equal to how much? It's 5. Now the scale comes in this way. It's pretty simply. You can mark the scale. This comes in 5, 10, 15, 20, 25, 30, so on it comes. Find the number of tomatoes with the weight between 0 to 2. There are 0 to 2. So you can work out 0 to 2. The area height is 2. Height is 2 into width is also 2. So that will be so much, turn up to 4. So from here, from the first initially, we need to make the scale over here and we can make it, right? Okay, right. Then they mention one of the tomato is taken, yes. So now I know the scale over here, therefore no need of working with this. I'll just write it here. Then it will be kind of easy for me to make it. It's 5, 10, 15, 20, 25, so on it comes. Right. Then one of the tomato is selected at random. Find the probability that this weight is more than 3 grams per day. Now, if you want to find more than 3 grams, we need to find the what you call the frequencies of each and every column. If I get the frequency over here is how much per day? 2 into 2 is 4. Here the frequency is, we already know that this value is 5. Here the gap is 2. 2 into 8 is 16. Here the gap is 2. 2 into 16 is 32. Here the gap is 1, 25. Then here it's 1, 10. And it's 9. Let's add them together and see whether we get the same frequency over here. 2 plus 5, 4 plus, we can make sure with that 4 plus 5 plus 16 plus 32 plus 25 plus 10 plus 9. Comes with 101. Sorry, this is 8, not 9. Right. Then we need to find the probability that weight is more than 3 grams per day. Now check whether how many elements are there for more than 3 grams. Here you can see 16, 32, 25, 10 and 8. Altogether there should be 91 information out of totally 100. So this is the probability for that, right? Estimate the proportion of the tomatoes, the weight is greater than 6.25 grams. That is quite interesting. Estimate the proportion of the tomatoes which is weight is greater than 6.25 grams. Now check with where the 6.25 grams means. I'll use a different color for that. 6.25 is somewhere here. 6. You need to find the area over here. Altogether, entire area should be counted with it. This is the proportion where it's more than 6.25. Then see whether here how many information? 8. I'll just get this one, 8. And here 10. And here 25. And but here we have another proportion. It's not the entire 32, only 6.25 to 1. So I need to find the area over here that is important for this. We know that 6.25 to 7, the gap is 0.75. Into height is, it's turned up to 16 out of totally 100. We will work out and see whether 0.75 into 16 is 12 plus 25 plus 10 plus 8 out of 100. 55 divided by 100 is, the proportion is 11/20. Right. Okay. Then let's go ahead with this. Using in answer part C, explain whether or not the median is greater than 6.25 grams. That's a quite important question. Now you can see, if you want to answer this question number D, 6.25, the proportion more than 6.25 is how much? Only 55%. That means proportion less than 6.25 is 45%. Then we know that median. We know that if you consider the median is a boundary which divides the information into exactly half and half. Median should be definitely, should be in between, exactly the information should be divided into two segments. Therefore, if you want to get the 50%, if you want to divide equally 50-50, where should be the boundary? Obviously, boundary should be somewhere over here. Then only you can divide this information into exactly 50% and 50%. Therefore, you can say median must be definitely what? Median must be definitely greater than 6.25. That's great. That's a factor to understand with this question. Right. Okay. Right. Then, yeah, I'll keep this information for a while. Doesn't matter. Right. Given that the mean weight of the tomato is 6.25 grams, mean is, and using answer to part D, describe the skewness of this distribution. This one also pretty interesting question, right? According to this one, they have given mean is 6.25. Then you know that median is obviously greater than mean. If the median is the mean is 6.25, from here, from this information, we already knew that median should be greater than that. If the median is greater than this one, so you can say it's a negative skewed. Negative skewed is the answer for this. That's a factor to understand with this question. The two of these 100 tomatoes are selected at random. Estimate the probability that both tomatoes weighed within 0.75 grams of mean. That is quite impressive question, right? I'll go back to the first part of the graph. We find the two tomatoes within the 0.75 gram limitation from mean, but the mean is 6.25, right? This is the way of doing this, right? I'll just erase this bit of it. This information is no need for me further, right? Then I just get mean is 6.25. That over here, 6 is here, 6.25 is here. There are 6.25 to 0.75 to positive side is this side. And 6.25 to 0.75 to negative side is this side. If you go from it to be 5.5. Now we want to see whether what is the probability of having a tomato within this range. So you can say that means this area. So you can find the answer for F. Probability of a tomato within 0.75 from mean is, the gap is put a 0.75 to this side and 0.75 this side is 1.5 into height is 16. It's turned up to 24. Selection of first tomato. Probability of the first tomato is how much then? 24 out of 100. Probability of second tomato. Now the second tomato, so we already picked the first tomato out of 100, that is within this range, right? Then in the first category, this is what? Within the range, therefore 24. Out of the range, there should be how much? 76. This is within the range and this is out of range. From here, within range probability is 24 out of 100 and this is out of range. It's out of 100. Then when you come up to, they ask about both within the range. That means it comes from here, within and out of range. When you come up over here, one tomato within the range is already picked. Therefore, how many tomatoes within range now? 23 range, out of range still 76. So this probability is how much? 23 out of 99. Therefore, the second probability should be 23 out of 99. Therefore, the total probability of both would be 24 out of 100 into 23 out of 99 would be the final probability. So you can work out divided by 9966. So it's turned up to 46 out of 825. That is a way of understanding this question. So I think it's clear with you. Here the gap is 0.75 and here the gap is 0.75. That's why the total gap is 1.5. Hope you understood, right?
Yes, sir.
Yes, okay. That is why this 1.5 came over here. An integer is selected at random from integers 1 to 50 inclusive. A is the event that the integer selected is a prime. B is the event that integer selected ends in 3, right? And C is the event the integer selected in greater than 20. So these are the three events. Describe the words event A intersection B. That means you should have the both properties A and B. What is A? It's an integer prime. It's a prime number, and as well as it should be ended up with 3. Its intersection, both properties should be there. So you can write the answer simply. Integer. You can simply write it's a prime. It's a prime number. I can say prime integer. Prime integer ends by 3. Ends by 3 in between 1 and 50 inclusive. If you cannot identify these terms much accurately, so just write it's a prime number, and as well as it's end up with 3, and it's in between 1 to 50. If you write it, that is quite enough as the answer for this question. Right? Okay. Then write down the probability of that integer selected is prime. Write down the probability that the integer selected is prime. Then see how many prime numbers are there. There are 6 plus 2. It's only selected as a prime. They have given only this definition. They didn't ask about any other variation. So the prime is entirely the facts where it's inside the circle A. 6 plus 2 plus 2 plus 5. 6 plus 2 is 8. 6 plus 4 is 10. It's 15. 15 out of how many altogether integers are there? But here there are 15, 16, 7. So altogether there should be 15 plus another 23 is there. 23 plus 12. Altogether there are 15 information. So you can count with that. It's 0.3 is the final answer for this question. Right. Okay. Then you have to be very particular about the question number C when you are working out with this. Probability of A union B union C complement. So A union B union C means everything inside this circle, inside this tree circle, that is coming under the union, not intersection. If they mention A intersection B intersection C means this area. A union B union C means everything over here. Complement means outside stuff. It's 12. 12 out of altogether 50. That's the probability for that. If you want, you can write 0.24, or you can write 12 or 50, or you can just write it as it doesn't matter. Right. Then the next fact of it. Read this question very carefully. Given that the integer selected is greater than 20. But C with it's greater than 20 means its element is C. It's given, that given, it's a given condition probability. Find the probability that it's a prime number. It's a prime number means it's A. Pretty simple. From the definition, you can say probability of A intersection C divided by probability of C. So A intersection C means this whole thing. 2 plus 5 is 7 divided by C. C means altogether over here 7, 8, 30. 7 over 30 is the final answer for this particular. Using your answer B and D. B and D, state with reason whether or not even A and C are statistically independent. This is pretty simple. If it is independent, what you can write with A? If the A and C are independent, probability of A intersection C should be similar to probability of A into probability of C. That's pretty simple. A intersection C is how much? A intersection C is, so I will just 7 out of 15.
Yeah. Yes.
7 out of 50 is equal to probability of A is 15 out of 50 into probability of C. Is yeah, it's 15, then 27, 30. 30 out of 50. Are these two similar to each other? Yeah, I think it's not similar. It's just two different facts. Yeah, they are not similar. So this is not similar. Therefore, it's not independent. Not independent. You can write the answer with this. Okay. Right. This is pretty cool. Then F. Given that integer is selected is greater than 20 and prime with it. Right. Now let's work out with this. What is the given condition with it? If it's a given condition is it's greater than 20 and prime. The greater than 20 means C and mean intersection prime. Prime means A. Find the probabilities end up with B. So it's turn up to B. That's a factor to find it with it. Then you can write according to the definition probability of B intersection C intersection A divided by probability of C intersection A. The A intersection B intersection is this bit. 2 out of 50 actually divided by C intersection A is how much? 7 out of 50. So the final answer is how much? 2 out of 7. That's the final answer for this question. Right with it. We'll come up with this question. A scientist measured the sanitary water X and recorded the temperature at which the water froze Y. Okay, for 12 different water samples. Then put the obviously from here you can say N is 12. Right. The summary statistics are listed below. All these facts are given. Find the mean and the variance of this temperature. So this is pretty simple. You can find mean and the variance of recorded temperatures. Temperature is X and the recorded temperature is Y. So you can say Y bar. Y bar is summation of Y divided by N. The summation of Y is minus 27 divided by 12. Right. So you get the answer. It's minus 2.25. Then we need to get the variance of Y.
Sir?
Yes.
Sir, why isn't it summation of X divided by N?
It should be, they ask about find the mean of the variance of recorded temperatures. The temperature fact is how much? The scientist measured the sanitary water is X and the temperature is Y. That is why I just put it as Y bar. Okay, is that clear?
Yes.
Right, that's it. Then sum is sigma Y. So you can say sigma Y squared over N minus sigma Y divided by N whole thing squared. Then summation of Y squared is given over here. 62.98 divided by, there are 12 samples, minus, this is minus 2.25 whole thing squared, because you know that summation Y divided by N already found from here. Right. Then if you do this, you get the answer 0.1858 is the answer for that. Then part B. 1. Right. Then they mentioned that they calculate the product moment correlation coefficient between X and Y. And the Priya believes that the higher of the sanitary water is the higher temperature at which the water freeze, right? calculate the product moment correlation coefficient between X and Y. Right, okay. Now look at this. To find X and Y, product moment correlation coefficient, we should know SXX, SYY, and SXY is not there. So initially we need to find SXY. That is summation of XY minus summation of X into summation of Y divided by N. The summation of XY is how much? Summation of XY already found it, minus 1190.7 minus summation of X. Summation of X is 504 times of summation of Y is minus 27 divided by 12. So you get the answer for the SXY become minus 56.7. Minus 56.7. Then we can find the gamma value. The gamma is SXY divided by the square root of SXX into SYY. So this is pretty simple. Minus 56.7 divided by the square root of 1674 times of 2.23. This gives you an answer of minus 0.92. It's minus 0.92. We'll be very particular about that. Right. Then here, this section today, most of students made it wrong too. Look at this. State with reason whether or not the value supports by Priya's belief. Then most of them thought, since there is a very strong relationship, as a common answer we used to write, yes, it's correct, because it says very strong relationship. But remember, now check whether what is Priya believes. Priya believes that the higher salinity of water is a higher temperature. That means, according to Priya's belief, when the first information increases, second information also should be increased. But what is the product moment correlation coefficient? Negative value. That means what is that one? There's a strong relationship. That is correct, but it's an opposite relationship.
Yes.
That means when the temperature increases, when the salinity level increases, the temperature should be dropped down. So you can say gamma is a negative answer.
So gamma is product
moment correlation coefficient. Is a negative. Therefore, the relationship is strong, but opposite. Therefore, what she believes is wrong. That's the fact we need to understand the discussion. Right. Find the least square regression line the y, x and y in form of y equals to a plus bx. Give the value when a and b for three significant figures. So you can say b is equals to sxy divided by sxx. The sxy value is what to do this one? We already got over here minus 56.7 minus 56.7 divided by sxx. 1674 hopefully. This value become minus 0.3, sorry, 0.033839, right? Okay, but they need the answer correct to 3 decimal points, so so we can put into the answer as 0.337 somewhere like around, and a is y bar minus bx bar. Y bar means minus 27 divided by 12 minus b. It's minus, there are two minuses comes over here, 0.0339 into x bar. X bar is summation of x, 504 divided by n, n is 12. Summation of x here, summation of y here. Right. Then if you work out with these figures, you get the answer as a is minus 0.827. 827. Therefore, you can write y equals to minus 0.827 minus 0.0339x. That's the answer where we need to get it today. Right. Okay. Then this one, part D. Estimate the temperature at which the freeze when the centigrade is 32. So this is pretty simple. You can substitute 32 into this equation. You can obtain this answer. Then you can write y equals to minus 0.827 minus 0.0339 times of 32. Hopefully, yes, 32. So you get the answer. Y is equals to minus 1.9. It's the answer for that, right? The coding W equals to 1.8y plus 32 is used to convert the recorded temperature from C to F. C to F, right? Find the equation of the least square regression line for what W on X is W equals to C plus DX. So what you need to do is this Y value should be replaced with W. That's a requirement. Then the what you call coding over here is W equals to 1.8y plus 32. Therefore, we need to replace with y. In this equation, y should be replaced. Therefore, I need to subtract y from here. W minus 32 divided by 1.8. Therefore, you can write the coded information is W minus 32 divided by 1.8 is equals to minus 0.827 minus 0.0339x. Right? So with that, that is the equation where we need to make it. So after simplification of this, you can cross multiply with 1.8. This side on you can do it. W minus 32 equals to 1.8. Sorry, we just do it like this. Minus 32 equals to 1.8 times of minus 0.827 minus 0.0339x. After simplification, you get the answer with a y equals to 30.5 minus 0.061x. That's the rest of it with the E. The rest of the part with the E, right? Then F. Okay, find the variance of the recorded temperature when the converted to F. That is pretty important, right? Converted to F. So we need to find variance of F. Sorry, variance of the new temperature value is W. Variance of W. We know that the W coding is like this. That means it's a variance of 1.8y plus 32. According to the variance relationship, we can write this is 1.8 squared into variance of y. We already found the variance of y in the previous, in part A. I think you got the answer for variance of y as 0.185833. Yeah, 185. So you can get the final answer. It's yeah, 0.602. You can use the calculator and obtain this answer. F1. This is F1 and F2. The product movement correlation coefficient between W and X. We know that product movement correlation coefficient is not affected by coding. Therefore, it's the same thing as the previous answer for over here. I think when you calculate the product movement correlation coefficient for B1, you got the answer minus 928. So you can say gamma is not affected by coding. That's a factor you need to understand with this question. Okay. Now let's come up to this question. In a game, the number of points scored in by a player in the first round is given by the random variable X with the point distribution. Right. Okay. Right. That means that the scores where they can take it, score is 5, 6, 7, and 8. The respective probabilities are 0.13, 0.21, 0.29, and 0.37. So that is fact. Then the first fact is we need to find EX. So simply you can find EX by 5 into 0.13 plus 6 into 0.21 plus 7 into 0.29 plus 8 into 0.37. So altogether you get the answer for EX as 6.9. 6.9. Part B, the variance. It's straightforward, we can't find the variance. Initially, we need to find what is EX squared. EX squared is 5 squared into 0.13 plus 5 squared into 0.13 plus 6 squared into 0.21 plus 7 squared into 0.29 plus 8 squared into 0.37. So you get the answer EX squared as 48.7. Then we can find the variance of X by the formula EX squared minus EX all things squared. The EX squared is 48.7 minus EX is 6.9 squared. We already got from here. From this information, you can get the value for variance of X as 1.09. 1.09, right? Then C, that is variance of 3 minus 2x. But according to the previous theories, we know this is plus 3 or minus 3 doesn't make any effect. Therefore, minus 2 whole thing squared into variance of x would be the answer. That is 4 times of 1.09 is 4.36 would be the answer for that. That's a simple way of getting the answer up to this extent.
So yeah, muted.
Right. Okay. Sorry. So yes, this is the first round information is given over here. The second round information is it's just like it's a uniform discrete distribution. Each probability is 1/4. The events 5, 6, 7, and 8. So if I just got input, it should be the y is 5, 6, 7, and 8. The probabilities would be each 1/4. 1/4, 1/4, and 1/4 like that it comes. Right. Okay. Write down the expectation of y. So simply you can find the expectation for this. Since it's a uniform discrete distribution, you can add the first term to last term and divide by 2. It's turn up to 5 plus 8 is 13 divided by 2 is 6.5. So simply you can get this expectation. Then part E is we need to work out this way. Find the probability of x is equals to y. Probability of x is equals to y. That means, like if you consider with the events y events are 5, 6, 7, and 8, and the respective probabilities are 1/4 each. 1/4. Then the probabilities where the 5 x is equal to 5. X is equal to y. That means 5 and 5. 5 and 5 is 0.13 into 1/4. Or 6 and 6. 0.21 into 1/4 plus 7 and 7. 0.29 into 1/4 plus 8 and 8. 8 and 8 is 0.37 into 1/4. If you work out this here, you get the answer. Totally 1/4 would be the probability. Right. Then the next is the important question. Right. Find the probability that number of points scored by the player in the first round is greater than the number of points scored in the player in the second round. Find the probability that the number of points scored by player in the first round is greater than the second round. I think it's better to understand the question if I use a diagram like this. I will just get this one. This is 5. So this is the first one. And this is the second one. The first round is 5, 6, 7, and 8. Second round is 5, 6, 7, and 8. Now we will count. This is what today. What is this element? First round 5 and second round 5. So the first round score is equal. This is first round 6 and second round 5. This is fine. The first round score is greater than the second round today. Then the next one is 5 with 7. This is fine. This one also fine. Then if you come up with this one, 5 and 6, the second round score is high, second round score is equal. This is correct. And this one also correct. And if you come up to the next one, it should be like this. 8 with 7. When other elements won't come up to the count because their scores are not, the first round score is not higher than the second round score. The first one is for the 6 and 5. First round 6, second round 5. We will mark this information. I think it's better. 6 and 5 and 7 with 5 and 8 with 5. Then the next one is 7 with 6 and 7 with 8. Sorry, 8 with 6. 8 with 6. The third one is 8 with 7. We try to calculate this value. First round 6 and second round 5. 0.21. Into now you can see all of them are multiplied by 1/4. If you want 1/4 plus 7 with 5. 7 is 0.29 into 1/4. I will write it here anyway. 0.37 into 1/4 plus the next one is for the 7 with 6. 0.29 into 1/4 plus 0.37 into 1/4 plus other one is for the 0.37 into 1/4. Then you get the final answer for this question today. If you work out with this, you get the answer 0.475. Just do it and you will understand that you get the same answer itself. Right. If you come up with this question today. In a survey, people was asked if they were used to the computer every day. Of these people under 15 years, 80% of said they use a computer every day. Of people 50 or above 55% says they use a computer every day. The proportion of the people in a survey under 50 years old is 50. So we can go into the tree diagram very easily for this question. So initially we have two categorization. It's below 50 and above 50. Below 50 proportion is P. Therefore, this value should be 1 minus P. It's obvious because we know that addition of these two trees should be 1, right? Then the people under 50, they mention use a computer every day. Use computer, not use, not. 80%. 80% means 0.8. Therefore, this should be 0.2. Then above 50, use a computer and not. They mention 55% use a computer every day means 0.55. And this is 0.45. This is a tree diagram for that. So that's pretty simply, you can get this answer for this. B. In a survey, 75% of the people say they use a computer every day. What is the proportion where you use a computer every day is this two. Then P into 0.8 plus 1 minus P into 0.55. They mention it 70%. That means 0.7. So you can get 0.8P plus 0.55 minus 0.55P is equals to 0.7. If it happens, this is 0.25P is equals to 0.15. With this, you get the answer P equals to 3/5. 3/5 is 0.6. So simply you can get the value for P as 0.6, right? Yeah. Then they mentioned part C. We'll work out the part C over here. One person is selected at random given that the person uses a computer. Yes, that's it. So it's a given condition. Use a computer. Find the probability that person is under, can I say, below 50. So as you can write, this is probability of below 50 intersection user computer divided by probability of user computer. Then put the below 50 user computer is P into 0.8. This is the branch. Below 50 user computer is this, that is 0.6 into 0.8 divided by probability of user computer. It's already given in the question over here. 0.7. So no need of writing it again and again. So with this answer, you get the answer as 48/70 is the final answer for this question. We'll come up with this. Right. In a factory, machine is used to fill bag of rice. The weight of bags of the rice is modeled by normal distribution with mean 250. Only 1% of the bags rice weight more than 256. Right. Okay, right, like this is the way. So we will just draw a small diagram for this. I think it's kind of easier for me to understand this question. Normal distribution is just like a symmetrical graph like this. The mean is how much for the 250. Then they mention only 1% of this 1% is more than 256. Only this proportion is 1%. 1%. Write down the percentage of the bags of rice weight between 244 to 256. Now you can see if you come up with 244, the gap from 250 to 256 is how much? 6. 250 to 244 is how much? That one also 6. Therefore, what can you say about this percentage? This one also 1%. Then they are referring to the percentage which is in between. That's what they were asking in this question. That should be how much? Then obviously it's turned up to 98%. So simply you can write the answer as part A, it's 98%. It's a percentage. Find the standard deviation of the weight of this bag. So this is pretty simple. I can use this technique over here. So you can say, we know that 1% of the bag is more than 256. No? That means there should be 99% of the bags less than 256. 99% means yes, the probability you can write it as 0.99. Right. Then what you need to do is initially make them into standard normal. Z is less than 256 minus 250 divided by sigma is equals to 0.99. Then for you can write Z is less than 6 over sigma is 0.99. Then you can write 6 over sigma would be, you can go ahead with the normal distribution table for 0.99. I will use, yeah, just give me 1 minute. You can go to the normal distribution. Yes, here we'll go to the S1 textbook. See, it's here. We'll go to this one table. We need to find the probability of 0.9900 today. So 9,900, the closer figure is 2.32. 2.32. So I'll use this one. 2.32. Therefore, you can get the sigma is equals to 6 divided by 2.32. So you can get the answer. 6 divided by 2.32 would be 2.59. 2.59 would be the sigma value for that. That's a way of getting the answer for that question. Right. Yes. Okay. Then when you come to the next part of the question, the inspection consists of selecting a bag of rice and random and checking of its weight within 4 grams of mean. If the weight is more than 4 grams away from the mean, right, then the second bag of rice is selected at random and checked. If the bag of the weight of each bag, each of the 2 bags of the rice is more than 4 grams away from the mean, then the machine is shut down. Find the probability that the machine is shut down following an inspection. Right? Initially, we'll try to find out from a single trial, what is the probability of it being within 4 grams from the mean. So I will just a small diagram for that one as well. That is for the idea, understanding the question today. Mean is 250. 4 grams gap is 254 to 246. So I need to find out the probability of X is in between 254 to 246. Initially, I want to make them into standard normal. Then it's turned up to 246 minus 250 divided by 2.59. This is obviously turned up to Z. 254 minus 250 divided by 2.59. So this is turned up to then Z is in between. If you go ahead with this, 246 minus 250 divided by 2.59, it's 1.54 minus 1.54, and this is 1.54. Then you can write this is probability of Z is less than 1.54 minus probability of Z is less than 1.54. Sorry, minus 1.54. This value is, you can go ahead from the table, 1.54, you can read it. 1.54 is 9382. This is 0.9382. This value you can get by 1 minus 0.9382. You get the answer 0.9382 minus 1 minus 0.9382. That is 0.8764. This is for a one back. This is within range. This is out of range. The within range probability is 0.8764. Then the out of range probability would be 0.1236. Second one also, that's one within range and out of range. This one also within range and out of range. The same probabilities come over here. This one also 0.8764, like that it comes in the same values, right? So under which condition the machine will be shut down? Look at this. Then read the question again properly. The first one is out of range, and if the second one also out of range, it happens. So you can say out of range and out of range. But the out of range probability is 0.1236 and means into 0.1236. So you get the final answer. You get it as 0.015. 0152 is the final answer for this. That's a way of getting the answer for this question. So when you're working on this discrete random variable, you can start with these events. What are the events over here? 1, 2, 3, and 4. We can start from there. It's kind of easier for us to understand this question. If X is 1, A into 1 is A, so it's turned up to A plus B divided by 60. If it is 2, 2A plus B divided by 60. This is 3A plus B divided by 60, and this is 4A plus B divided by 60. Then we know that since this is a probability distribution, if you add them together,
it's equal to 1.
Equals to 1. That's great. Good. Then A, 3A, 6A, 10A, B, 5B equals to, if you cross multiply 60. Then if I divide everything by, we can divide by 2. Sorry.
4B, right?
It's 4B. You can divide by 2. It's turned up to 5A plus 2B equals to 30. Right. It's my first equation. Just keep it this answer. It's my first equation. So that's the first part of the question they're referring to. B. They have given F3 is 13 over 20. Find the value for B. What do you mean by F3? Probability up to 3. Probability up to 3 is what? It's 13 over 20. So you can write addition of these three. So you can say A plus B over 60 plus 2A plus B over 60 plus 3A plus B over 60 is equals to 13 over 20. So they're making you get 6A plus 3B over 60 is equals to 13 over 20. But from here you can get another equation. This is cancelled with this is 3. It's 6a plus 3b is equals to 39, or you can write 2a plus b equals to 30. This is my second equation. Right. By solving this to a simultaneous equation, you can get the answer for a and b. I will just do it. It's 5, 2 and 30. The one is 2, 1 and 13. It's turn up to a equals to 4 today. And b equals to 5. Okay, right. Then, yeah, that's what you'll get it. Then, obviously, these probabilities, what happened to these individual probabilities? This is turn up to a plus b divided by 60, 9 over 60. This is 8 plus 5, 13 over 60. Then 3 into 4 is 12, 12 plus 5 is 18 over 60. 21 over 60 is the answer for this one. Given also y equals to x squared, find the cumulative distribution function of y. Right. Then this is pretty simple. Given that y equals to x squared, we need to find the cumulative distribution of y. So initially, we will mark the distribution of y. What are the y elements? It's x squared. 1, 4, 9 and 60. The respective probabilities are 9 over 60, 13 over 60, 18 over 60, 60 and 21 over 60. Therefore, you can get the capital Fy is 9 over 60. At this 2, it's 22 over 60. Then, yeah, 22 over 60. And if you add that to this one, that is that 18, 3 into 24 is 12, 12 plus 5 is 18. Then 22 plus 18 is 9 over 60 and 22 over 60. That is correct. 3a plus b, 3 into 4 is 12, 12 plus 5. 12 plus 5 is 17, not 18. So it's turn up to then 17. This is 17. So this is also 17 today. It's turn up to then 39 over 60. And this is 60 over 60. You can get the final answer in this format. That's a way of getting the answer for this.